So what really drives science forward? For centuries, it's been this deep, unshakable curiosity in the human mind. But today, that timeless drive is getting a massive upgrade. It's being paired with one of the most powerful tools we've ever created, artificial intelligence. And today, we're going to explore how this combination is completely changing the game for how we understand and even predict human health. Yeah, let's start right here because this quote just nails it. It's not just about crunching numbers or getting grants. At its heart, every single scientific breakthrough starts with a question, right? A genuine, burning desire to know something. That's the spark. It all begins right there. And if you want a perfect example of this in action, look no further than the biologist and Nobel laureate John Gurdon. This is a scientist who was so driven by that pure curiosity that even after winning the Nobel Prize, he was still in the lab at 86 years old running his own experiments. Now that is dedication. It's a passion that's fueled by nothing but the love of discovery. So that same spirit, that same fire that drove John Gurdon his entire life, is now being amplified on a scale that's just hard to even imagine. We're going from the passion of one scientist in a lab to a massive global effort, and it's all being supercharged by technology. Let's take a look at the new frontier this has opened up. We're at this incredible turning point. We are moving away from just looking at what has already happened in our health to predicting what will happen. And the first major innovation we have to talk about is how artificial intelligence is starting to forecast our individual health futures with with an astonishing new level of detail. The key idea here has a name: disease trajectory prediction. Okay, so what does that actually mean? It's not about just one diagnosis, like you have X. Think of it more like mapping out the different paths your health could take over your entire life, using massive amounts of data and powerful AI to see how one illness might lead to another and when. And listen, this isn't some far-off sci-fi concept. A groundbreaking paper published in the journal Nature, which is a huge deal, just unveiled a model called Delphi 2M. And get this, it's a large language model, the same kind of tech behind things like ChatGPT, but it's been trained specifically to understand the incredibly complex story of human health. So what can this thing actually do? Well, the real-world impact it's just profound. We're talking about medicine that's truly personalized, with health plans built just for you based on your predicted future. This tech helps us finally understand why some diseases seem to show up together. It can guide public health policies for entire countries, and it gives doctors a whole new way to think about our long-term health. It's a massive question, right? Just stop and imagine for a second, going to your doctor, and they're not just treating the symptoms you have today. Instead, they're helping you navigate a health journey to actively avoid diseases you might be at risk for 10 or even 20 years down the road. That's the incredible shift we're talking about here. But here's the thing. These super powerful AI models, they're only as good as the questions we ask and the data we give them. So to really predict disease, we have to look even deeper. The next piece of this puzzle is a huge shift in how we think about what causes disease in the first place, moving way beyond just our DNA. For a really long time, the focus was all on linking specific genes to specific diseases. But the new frontier, the really exciting stuff, is in what's called gene-environment interaction models. The idea is simple but powerful. It's not just about the genes you carry. It's about how those genes interact with your lifestyle, your diet, where you live, everything. Our health is basically a constant conversation between our genetic blueprint and the world around us. Okay, so we've got these incredible new ideas and these powerful AI models. But what are the researchers on the ground actually using to build this future? Let's pop the hood and take a look inside the modern researcher's toolkit. What is this number? 88.5. That is the absolutely staggering impact factor for The Lancet, one of the top medical journals in the world. So why does that matter to us? Because they just released the massive global burden of disease dataset for 2023. And this dataset, well, it's the fuel. You can have the most powerful AI model in the world, the most powerful engine, but without fuel, you're not going anywhere. This massive, high-quality data is exactly what models like Delphi 2M need to learn and make these incredible predictions. So on a day-to-day basis, researchers use very specific tools to make sense of all this data. For instance, they might use a software package to create something called a heat map, which is a way to visually see complex patterns that would be totally invisible in a giant spreadsheet. And to build these kinds of tools and run their analysis, more and more they're getting a little help from AI.
Tools like Codex are basically AI programming assistants. And it's not some abstract thing in the cloud. It runs securely right on the researcher's own computer. It can actually read their code, understand what they're trying to do, and then automatically write new code, fix bugs, or help run an analysis. It's like having a brilliant co-pilot that speeds up the entire process of discovery.
Now, here's what gets really exciting. The tools and the knowledge that are powering this whole revolution, they are more accessible than ever before. So if any of this has sparked your curiosity, there are some really clear paths to start learning about this stuff today.
So there's this major hub for the AI community called Hugging Face, and they offer a whole set of incredible courses. And get this, they're completely free. You can learn about the very same large language models we've been talking about. You can learn about how AI learns how to build AI agents. The core technology is right there waiting for you to explore it. And if you're someone who really wants to understand the engine under the hood, the open source textbook Think Bayes is a fantastic resource. It actually uses the Python programming language to teach the core ideas of Bayesian statistics, which are fundamental to how a lot of these modern models work. So look at that. We've kind of come full circle. We started with the intense personal curiosity of one scientist, John Gurdon, working away in his lab. And we've ended up here, with globally accessible, incredibly powerful AI tools and open source knowledge that anybody can tap into. The pace of discovery isn't just steady anymore, it is accelerating like crazy. You see, that fundamental human desire to understand, that curiosity, is still the engine driving all of this progress. But now, for the first time ever, we have a map unlike any we've ever had before. So the only question left really is, where will you let your curiosity take you?